Looking at statements involving quantifiers, the universal quantifier, the upside down and, means for all. The existential qualifier, a backwards E, means there exists. Okay? So examples: translate the following statements into everyday language. Also determine whether or not each statement is true, justifying your answer. So for the first one here, upside down A means for all. So this says, or this means, so it asks, put in everyday language, that the square of any real number is greater than or equal to 0. Okay? So if you think about that, the square of any real number is greater than or equal to 0. Well, that has to be a true statement, because if you square a number, it's going to become positive no matter what it is. Okay? So this is a true statement. As squaring a number even a negative number makes it positive. And also 0 squared is 0. Okay? Also 0 squared equals 0. Okay? Next one. We have the E, the backwards E, which means there exists. So this means that there is at least one integer, because it's dealing with Z, one integer such that the sum of the integers squared and twice the integer is prime. Okay? Is it a true statement? Well, 1 squared plus 2 times 1, so if n is 1, would be 1 plus 2, would be 1 plus 2, which equals 3. Okay? 3 is prime. Therefore, this is a true statement. You only need one example when you're talking about the existential quantifier. You just need one example that works. For all, you need to prove that it works for everything. So backwards E is a there exists. So this is saying there exists some n, which is a real number, such that x squared equals the square root of x. Okay? So this means that there is at least one real number whose square is equal to its square root. Okay, can we find an example? 1 squared equals the square root of 1, which equals 1. Therefore, this is a true statement. Again, you only need one example that works. Last one is a for all. So for all integers n, the number 5 times n is even. So this means that the product of any integer, okay, any integer and 5 results in an even number. Okay, so if I have let n equals 3, 3 times 5 is 15, that is not even. So therefore, this is a false statement because it needs to be true for everything. Okay, this is a false statement. So you have to remember that a universal quantifier has to be true for everything. So you can find one thing that doesn't work and you've proven it false.